This is a DIY crystal radio. They were very popular in the 1920s. They require no external power to operate, no batteries, no power, nothing. They operate strictly on the radio waves that are coming in. So if you're looking for something, an emergency radio where when the power is out or you won't have batteries or whatever, this is the thing to have. This one is made primarily from scraps. In fact, you can get almost all these pieces just from pulling other stuff apart. And there's only three major components. There's this coil, which you make yourself. There's this crystal diode, which is kind of the miracle of this, is what makes it work. And it comes from Radio Shack. It's very cheap. And then another little resistor, which you can pull out of something, or you can again buy from Radio Shack for almost nothing. There's a piece of plastic tubing. You can also use a hard cardboard tube. Some wire, which you can get out of an old transformer. I happen to buy this wire, but you can get it out of an old transformer. Spring clips. You don't really need the spring clips. A lot of people just use the brass screw and brass washer to hold the wires down, to give you some contact points. There's this, which is the tuner, and this is nothing more than a stainless steel big size bicycle spoke. So it's been shaped into what I need. There's a wooden bead on top to hold on to. Let's see, going over this way, the diode again, the resistor, and then it goes back to the coil, and as you can see, that's it. There's no other components. So it's great for those times where you need a radio, you don't have batteries, you don't have power, and they're also just fun to play with. So anyway, let me show you how to build this, and it's a weekend project, very simple, so let's get started. Two of the main pieces I have, I've got the piece of wood, which is 21 by 17 and a half, if I remember right. Yep, 17 and a half. I'm using roughly a 2.5 inch. I think this is actually 2 1/4 inch. 2.5 is supposed to be the specified size. I think 2 1/4 will work. Thin wall PVC tubing, 7 inches long, or call it 17 and a half centimeters. Piece of tubing that we looked at earlier, and what I'm going to do is I'm going to wind this with wire, and we just need some enameled wire, and you can get it from, for example, like an old transformer. Use the heavier windings, not the lighter ones, but heavier windings. This is from ballast, from we call it fluorescent light. This is the ballast wire, so I unwound that. What I'm going to use this. It's just a heavy wire, heavy enameled wire I bought, and I got it from Radio Shack, someplace like that. So, okay, we'll take the next step. I'm going to show you how to wind this coil. I'm going to use a small one because the big one is too hard to keep on camera. It keeps going off the edge of the camera. So, it works the same for the big one. I just cut off a small piece. So what you need is you need a hole on each end of the tubing, and then you're going to start your wire in one hole, and you're going to wrap it nicely. So you reach the other hole, it'll go through there, and then you'll just bend it over. You can put tape on the inside if you'd like to hold it. But let's get to the wire. Now, one of the tricks is you need to have your wire, it has to be smooth and unkinked. So see this first part, it's not very smooth, not very unkinked, so we'll just put that inside the thing and get rid of it. You want to make sure your wire is smooth and unkinked. You notice I'm using the toilet tissue holder to hold the spool of wire. You do not want it to come off the end squiggly and spirally. You don't want the wire to be kinking. This is the most difficult. Winding this thing is the most difficult part. It's not really that hard. It does take 2 hands, which is one of the reasons I'm using this. So what you want to do is you want to get yourself a pretty good length of wire in here, maybe 6 inches out of here. Just bend it over sharply in there, like that. And then you want to start wrapping it nicely. And it doesn't matter which way you go. And the first turn is very important because it is how everything else is going to follow. If it's crooked, all the others will be crooked. So you want it to be tight and straight. And you see this gap? That gap is no good. So you push them together Again, push it together. Now one trick that helps hold it together is you can put a little bit of white glue on here. I'm not going to do that because it's a little bit messy for the demonstration. It'll make things harder to see. But just put a little bit of white glue on here, spread it out as you go along. It'll help this stick to the coil. You do not want any kinks. You don't want any, one of the problems with glue is you'll get little balls of glue underneath the wire, and then it will not lay out nicely and keep the wire tight. You want these coils very tight. And that one's not beautiful. And you notice what I'm doing is I'm pushing it this way and I'm turning it at the same time. This is why you need both hands to keep the tightness on there. Again, the glue helps. Now you may ask, would this coil work for radio? And the answer is yes, it would. It would not pick up very much. It would have a very limited range of frequencies. The longer the coil, the greater the range of frequencies, but it also is harder to tune because your tuner rod has to get longer and longer in order to sweep across here. I'll show you that, what I mean. Okay, so I'm just going to continue this off camera, and then I'll show you as we conclude how we finish this out. So here we're getting towards the end. This wire does have a few kinks in it, which I'm pushing out as I work it on here. There's our hole. Maybe 4 or 5 more turns around here. Keeping it tight. Yep, there's a kink right there. So you want to absolutely make sure there's no kinks. Beauty counts in this. Don't let go of it because this wire will come springing off of here and then you get to start over. Okay, we'll call this good here. Okay, so here's the last hole. Hold this tight. Give yourself plenty of spare. Cut it off. And the second hole we drilled right here, we're going to tuck this wire down inside there. Again, we don't want to kink it. Okay, I got a little bit off. Again, the glue would help. Pull it tight, pull it tight. Don't break it, but pull it tight. Okay, and then I'm going to bend it sharply inside here so it won't come loose. Again, tape or whatever glue will help. But there's the coil, not too bad. And of course, again, your coil will be 6 to 7 inches long. The coil I made just has too many windings. It has 170 windings, which is ridiculous. Somewhere between 80 and 120 is pretty typical. But anyway, that's how you do it. And what you'll do is we'll mount that. I'll show you that with the other coil. We'll mount that. And that's it. This is, again, the hardest part. So if you can do this, the rest of the radio is super simple. There's one end of it. There's the other end of it. Anyway, it's close wound, and I used some glue. Now I got to clean the glue off, and then I will spray it with some clear acrylic, and then the coil will be done. Most of these radios, there's just a screw from here to this bottom base piece, and they'll put a few washers in here to space it because you do not want the coil to touch the base. I made this little block, and as you can see, it's kind of crude, but I saw it into the block into roughly the shape of this tube, and then I chiseled it out, and I use a rasp, and it's fastened on the bottom with a couple of screws, and then of course it's fastened right here with one screw, and same on the other side. Spring clips, and mount a couple over on this side for the earphone, and a couple here for the diode, and a couple here for the antenna and ground, and then we still need to find our wiper, which goes from here to here. You can see on this end all that we've done is run the wire out of here, and I've soldered it. You don't have to solder it, but I soldered it on the clip, and that will go here. So I'll put a screw in there. You can see that I've just looped the wire around here and soldered it on there. Soldering is best. You don't have to do it, but if you can, it helps a little bit. Note that the enamel's been scraped off of the wire. That is one of the trickiest parts. You've got to get that brown coating here off of there until you get a nice shiny copper. It should be this color like this. You can see a little bit right there at the end of my finger. You get that enamel off of there, put it around there, solder it. If you're going to use a brass washer instead of these clips, that's okay too. Just loop the wire around one of the washers, the brass washers, and solder it on there. And you cannot use stainless. I mean, you can use stainless if you're not going to solder, but stainless and solder don't get along. So I recommend brass for that reason. But you can do the same thing. You put the wire loop around here, solder it on there, and then when you put the screw through there, it'll make good contact. The brass clip and the stainless screw. And over here on this side, I've got the brass clip. Let's talk about these two clips right here. These are for your earphones. And how far apart should they be? Well, the answer is just a little bit farther apart than your resistor. This is our resistor right here. This is a 10K ohm resistor. And it just needs to go in there and get clipped. If you're using washers and screws, again, just the distance needs to be in there so that you can comfortably wrap the ends of this around. So if you're using screws and washers, you may want to bring these a little bit closer so you have some space to wrap the end around there. And the same with the diode. Exactly the same issue with the diode. Make sure that you have enough distance in there that you can comfortably connect it. If you're using spring clips, you want to be just a little bit, there we go, just a little bit longer. You want the wire just a little bit outside the clips. And if you're using screws and washers, you'll want to bring them in a little bit closer so you can wrap the wire around the screw and the washer setup to hold it in there firmly. You don't have to use those spring clips I've been showing you. Another technique a lot of people use is just a screw and two brass washers. And what you'll do is you'll just run the wire that you want to connect around wrap it around between the two washers, and when you tighten it down, it'll pinch it, it'll clamp it in there. It's a little less convenient than the clips, but does work very well. It's the original method of tightening in or making connections. Now, in between the wiring that goes from here to the wiper and then over to the first clip on the diode, which will be here. This is the only tricky part of the wiring. Is it will look like this. And I got a brass washer and just a piece of wire, so the wire is going to go from here to there, and it's going to be screwed down right here for the wiper. So it's going to look like that, and the wiper is going to go on to here like that. What I did to make this is I just took a piece of copper wire, and you can see it's relatively simple. I made a loop on each end and soldered it. Again, you don't have to solder it, you can wrap it, but I prefer solder. I soldered it to this wire, to this brass washer, soldered the wire to the brass washer. And then again, I made a loop over here. I was trying different types of loops to see which one would work. And that'll be the connection from here and to the wiper. Let me talk briefly about the wiper. This is what you use to select the station with. In this case, it's just a length of stainless steel, a heavy-duty bicycle spoke. And I've heated it up and put a loop in this end of it to put the screw through to hold it down. It's going to go right here in this hole. and when the screw is in place, it'll push down on here and apply some pressure, and then that's used for selecting the station. On the other end, I just bent the knob up, bent the wire up a little bit so I can put a knob on there to help. The knob is just to for your fingers, because if you touch the wire while you're tuning it, it changes the tuning. So that's all there is, just a knob on the end of it. Okay, so that's the wiper. So I've got this loosely in place here, and when you go to put on the wiper, you need a washer down here, which is the one that's contacting this wire. And then you'll also need another washer on top of the screw, so that when you turn this, it moves nicely between the washers. Without these washers, it'll jam and try to unscrew the screw and so on. So what we're going to do is we're just going to take and put this here like that, put this in here, and then it screws into the board, and you use this for adjusting the tension on the wiper up here. And so that's how the wiper is installed. Well, this is pretty much it. We got the wire coming out of this side of the coil, comes down here. It's in this case it's soldered onto this clip. A resistor will go across here, and then the earphone will be connected to here. These two clips are just screwed together. If you're using washers, you would just have a screw and a few washers on it to make the connections. Diode will go here, then there's the wire here to the wiper, as we showed you earlier. Wire goes over here to this contact, which will be the ground. We'll hook our ground wire here. Back here is the antenna wire. This clip will go to our antenna, and then of course, as we showed earlier, it goes into the coil. So that's pretty much it. Yeah, that's the assembled piece. I'll show you some finishing pieces. We need to still remove the enamel off of this wire so that the wiper can touch it. If the radio is not going to work, it's probably because the enamel has not been removed from here or from one of these two end pieces. That's the most common error. Getting that enamel off there can be a little tricky. I'll show you that here in a second. To remove the enamel, you got to get this enamel off of here, because this has to make a good electrical contact to the coil. To get the enamel off of here, you want to stripe across here where the enamel is gone. What I did is I start out with a piece of sandpaper, and I put it around my wiper like this. Like this, and what will happen is it will mark. You can see it's scratching the copper wire, and then what you want to do is, once you've got a good mark on where it's going to touch, take your sandpaper and sand up and down this direction. You can see it shining up nicely. And work on that until you got a nice clean copper strip across here. Then take a brush, toothbrush, rag, or something like that, piece of tissue, and get the copper and enamel dust out there. If you don't get the copper dust out there, it'll short between the coils, and you won't get a very good separation. So just clean it out with a brush, and that'll be that. When it comes to these connections here, to scrape the copper or the enamel off the copper, I use a combination of a sharp knife like this and sandpaper. I don't use, a lot of people will burn it off. I don't like to do that. It softens the copper. So just use a sharp knife, scrape the enamel off, get all the enamel off you can, make sure it's shiny all the way around the wire before you make your connection. Almost forgot to mention the important part. Put your diode here. Don't forget that. Doesn't matter which way it goes. Usually you have to worry about which way the diode goes, in this case not. Your resistor here. Resistor has no direction either. And then the last thing is clip in your earpiece, and again, doesn't matter, just one wire on one side, one wire on the other. I put a little extender on it, which is why the wire is a different color, but that's it. Ready to use. So this is it in use. Got an earphone over here on this side, it's connected up over here. Got a ground, just connected to the ground from here to, this is an air conditioner. The antenna, it's hard to see the wire, goes up here like this. It goes to this insulator, and then all the way out there to that other fence. And on the other fence, it's connected by, again, a piece of string to keep it from touching the metal. Just be careful not to run it near electrical lines. You notice we have got no electrical wires or anything out there. You don't want to run it across electrical wires or anywhere near electrical wires. And make sure your ground has nothing to do with electricity. It's going to something like a water pipe or something. And for operation, that's pretty much it. Just listen and tune. So does it really work? Well, you have a listen.
This style of crystal radio is the easiest to build, it's the most reliable, but it does have one drawback, and that's this wiper arm. The rod likes to, you can see it bend as I start to go this way, and it bends and then releases, bends and releases, so it makes it harder to tune. A lot of times you'll get right on where you think you want to be, and then you let go and it kind of snaps back to another position. The other thing is, out here in the middle, it's very tight, but as you go farther away, it becomes kind of loose on the coils. And it all has to do with, you know, some geometry and then how smooth this thing operates. And I've never been able to get this, you know, to operate really smoothly. So let me show you an upgrade that you can do on this radio that I've been working on, and I think it's going to help a lot. There's a loop on the bottom of this shaft, like this, and there's one on here. And the problem is that when you're dealing with a stainless steel bicycle spoke or stainless steel rod or whatever, it's really hard to bend that into a perfectly round circle, and it's really hard to get it exactly the size you need for the screw. And so what happens is this thing slides around, it binds up. I found a big piece of copper and I started going like this, and okay, what if I did this or that? And I thought, what if I did that? I hammered this thing oval, put this in there, and then hammered on that. This thing would be inside here, and I could drill a hole of whatever size I need, exactly centered, and it would fit the screw very nicely. So this is the result. You can see the loop that's inside there. This is the copper tubing. It's been smashed. I put a board on each side and hit it so that it would mold itself around that stainless wire. And so now I've got a hole exactly where I need it. It's the right size for my screw. And when I put it between two washers, I can either use a spring like on top spring loader like I did in another video. But as you can see, that will slide nicely. I can get that hole to stay right where I want it. It will line up because of the screw. It will line up into the top of the mount, and it will move very nicely. So I won't have it binding and jerking and whatever. I can apply less pressure. I can use a spring. I'm also thinking about using a felt pad to apply a little pressure. You can see that, first of all, these wipers are straight. There's no angle to them. There's no bend. That's because of these towers. The tower is about 1 centimeter shorter than the height of the coil. So that's the trick there. There's a little bit of downward pressure, but not a lot. And that really helps the smoothness of of moving the wiper. This is the bottom of the radio. You can see the two towers right here. The towers are held on by 2 screws like this. Let's talk about how the wiper arm attaches to this tower. You can see back here there's one that's assembled. And above it, you can see here is it's a brass washer. And above the brass washer is a piece of felt which acts a little bit like a spring. And you can replace that with a spring, in fact. Then there's a stainless washer, and then there's another brass washer. The only reason the little brass washer is here is because the hole on the stainless is too big for the head of the screw, so you could do away with that if you have a smaller hole in your top washer. But that's it, and it sits back in here, as you can see, like that one back there. It's already very smooth and it doesn't wobble around, doesn't bind. When you're making crystal radios, you need to wire in components like over here, and you need to clip things in. These fanny stock clips have been traditional for a very long time. The problem is they're becoming more expensive and harder to find. And in fact, the original crystal radios used something like this. Let me do a close-up and we'll show you what we're talking about. This was the traditional method of making a contact point. It's just a couple washers and a screw. It is best to either use stainless or brass in both the screw and the washers. And there's just a very small trick to making it, and I can show you, and we'll go through the process of doing that. If you just use two flat washers like this, you can see they form an angle when you try to screw the screw down and tighten it. And what will happen is it'll pinch it and it'll just pop that wire, just a piece of wire in there, it'll just pop that wire right out of there. So the only trick to this is you want to bend that top washer just a little bit, not too much, because if there's too much of a bend to it, it'll make a hollow spot and the wire will just pass right in and out. It won't tighten down. But just a tiny little bit of bend to that top washer and it will help hold it in there, and then when you tighten the screw down, it won't pop out. So let's do that. Now what we're going to do is we're going to take one of our two washers and we're just going to bend it. Now you might be able to use pliers. These are too thick. I haven't had any luck with pliers. But I just got it clamped in the vise, and it's a little bit more than halfway above. So all I'm going to do is tap it with a hammer. There's no trick to this. These are kind of thick. I'm going to check it. Yeah, I got a little bit of a bend to it. If I've got too much of a bend to it, I can just lay it on a flat surface and tap it out. Let's see, yeah, you see that? Just the tiniest bend to it. We'll get the other washer and we can make a comparison to it. This will be the top washer. So, like this, get it in focus. And you see that? It's just the tiniest little gap in there. So this side they fit tightly, and this side not. But that's all you're looking for, is something like that. And that way when it clamps down, it will push the wire to the inside rather than trying to pop it out. Okay, well that was it for creating contact points for crystal radios out of washers and screws. The question I've been asked most about crystal radios is, does my coil, this part of the crystal radio, does it have to be exactly like the one I made? And there's a yes and no answer to this. For this type of crystal radio, you need an inductance in this coil of about 531 microhenries, and that will self-resonate about 1 megahertz. And the AM band goes from 535 to 1605. So it's 0.5 megahertz up to about 1.6 megahertz. So that's the 1 megahertz is right about in the middle, so that's a good sweet spot for your coil to resonate. So what we're going to do is we're going to go through some common pipe and wire size combinations that's going to give us that. So if you don't have exactly the same piece of pipe that I've got laying around, maybe you've got a 2-inch instead of 2.5, or you got a 3 instead of 2.5, whatever it is. Yeah, so we'll go through some combinations that'll work for you. Note that metal pipes or painted pipes will never work. So yeah, people will paint them black and wrap the wire around it. It looks cool, but it doesn't work. Crystal radio coils. Okay, generally speaking, these are going to be equivalents. So we're going to change the pipe size and we're going to change the wire size. But there's going to be trade-offs when we do that. They're not going to be exactly the same. There's some good and bad when you make these trade-offs. So for example, a bigger diameter pipe or coil is going to be more efficient, so you get more volume, get more sound out of it, but you're going to get a shorter coil, and that's easier to make, and you'll get a shorter wiper. That's this part right here. However, on the downside, shorter coils mean less tuning and more crosstalk. You've got less area to try to snag that signal, to try to get that, tune in that radio station you're listening to. And as the pipe gets smaller, the required length goes up and the number of turns goes up. So you'll go from something like this to something like this. And as that happens, you can see what happens to the wiper here. It goes like this and starts to trail off. So you need to have a longer wiper arm. Bigger diameter wire, you get less resistance loss, so you get more volume out of it. It's easier to work with and it lasts longer. When you slide this wiper back and forth across there, it rubs on the copper, and after a while it will wear out. It's easier to place the tuning arm on an individual wire, so you get better tuning. So if you got a really big tuning arm compared to the wire, if the wire is really skinny and you try to set it on there, yeah, you're going to end up setting it on multiple wires at the same time. And we'll go over to the bench and take a look at that, and I can show you what I mean. But yeah, it's easier to tune when you have bigger wires. However, you need more turns. So you're going to end up with a longer coil and a longer wiper arm like this. So you can see these trade-offs are happening. As the wire gets smaller, the required length and number of turns goes down. So note that when you're measuring your wire thickness, the diameter of the wire, when the manufacturer tells you that, it's usually just the copper part, but you need to know the diameter of the wire that includes the enamel. Okay, so let's go over to the bench and take a look at some real life examples of what's going on. These are two crystal radios. They work roughly the same way. This one's a little bit more advanced. It has a special section for the antenna, and we can ignore that. But you can see that this section is much shorter than this section. This is the tuning part over here on the other side of this blue line. And on this one, this is the tuning section. And you can see the difference it makes going from a much bigger form to wrap your wire around compared to a smaller form like this one. Back again. The wire I like to use is 0.91 millimeters or 19 American wire gauge. It's bigger, it's easier to work with, it's easier to tune, and yeah, that's just what I prefer. Note that down below, these figures are going to be rounded up where necessary. So for example, instead of saying 243.5 turns, it's going to be 244, because you know that half a turn or 1/3 of a turn, whatever, is not going to make a difference. Okay, so the first thing I ever made, the first crystal radio I ever made, used a toilet paper tube. And one of the reasons you don't want to do this is they're very weak. People have asked me about this. Yeah, they get bumps, stepped on, whatever, and all that work is gone. But there's some other disadvantages. For example, it is 1.84 inches in diameter, but the tube is only 4 inches long. And why do I have this in red? Well, let's take a look. If we use 19 wire gauge, the length of the coil needs to be 8.65 inches, and the tube is only 4 inches long. So it's not going to work. It would require 244 turns, and half of those would be off the end of the tube somewhere. If we use 22 wire gauge, then we're talking about a length of 4.74 inches, still too long, but it's coming a lot closer, and it only requires 187 turns. So you see what's going on here. As the size of the wire gets smaller, we need fewer turns and the coil gets shorter. 24 gauge, the length would be 3.2 inches. Okay, so now we can fit that on our toilet paper tube, and 159 turns. So yeah, that would work. Let's jump up to 1.5 inch PVC, which is the blue stuff, like this. The actual OD is 1.9 inches, and that's what we have to use for calculations, or 48.26 millimeters. If we're using 19 wire gauge, then the length would be 8.4 inches, so we can just cut ourselves off a piece that's 8.4 inches long. Usually a little bit longer because you mount them on the ends, but this is the length of the wire wrappings. And that's going to be 235 turns. If we've got 22 wire gauge, then it's going to be only 4.5 inches. Notice that it fell almost in half, and 178 turns. And if we use 24, which is getting kind of thin, it's going to be 3.1 inches, which is very short, and it's going to be 152 turns. Now you can see up here with 8.4 inches, that arm, the tuning arm, has a long way to travel, and you can separate out the stations much more nicely. When you get down to 3.1, if you've got like 40 stations, that's going to be really hard to get them out. There's going to be a lot of crosstalk. Stepping up to 2-inch PVC pipe, the actual OD is 2.375 inches or 60 millimeters. At 19 wire gauge, the length of the coil is going to be 5.74 inches, 160 turns. Notice here what's happening compared to this. So we went from like this to this, and these aren't too far apart, but we got thicker wire, which is a good thing. 22 wire gauge, 3.22 inches and 127 turns. And 24 wire gauge will give us 112 turns and a coil of only 2.25 inches. So that's getting awfully short. Let's go through a couple more and see how it plays out. So my favorites are the 2-inch and 2.5 inch. And here we go with the 2.5. The OD is actually 2.875 or 73 millimeters. With 19 wire gauge, the length is 4.3 inches and 120 turns. 22 will give us a 2.5 inch. Yeah, so that's like that. Yeah. And 99 turns, and 24 will give us a length of 1.79 and 89 turns. So yeah, these are getting awfully short and not very practical. However, when we were kids, we used to also build a spy version of these crystal radios, and this is what we would do. We would use very fine wire, which doesn't hold up very well, but we'd use very fine wire, and you could build a very small crystal radio. Now for the 3-inch PVC pipe, the actual OD is 3.5 inches or 89.8 millimeters. 19 wire gauge gives us a coil length of 3.25 inches and 91 turns. 22 wire gauge is 1.97, about 2 inches and 78 turns. And 24 wire gauge is 1.44 inches long and 72 turns. So that's really tremendously short. Okay, so generally speaking, what we're seeing is as the wire gets smaller, the required length of the coil goes down and the number of turns goes down. And as the pipe gets smaller, our form that we're wrapping on, the required length and number of turns goes up. So these are some good numbers you can kind of pick through here and decide, how big you would want your coil to be. Again, I prefer the 2.5 inch pipe and the bigger wire. But this is part of the fun of crystal radios. You can experiment and try something with a different size diameter and just see how it works out for you. Today let's talk about making a simple DIY crystal radio antenna. By the way, these can also be used for shortwaves. Important note, I'm going to stress this many times, all outside antennas need lightning protection. This video is not about that. It's something you have to learn about and use. You need things like lightning arresters that'll jump a strike to ground. What I do is when I'm done with my antenna, I take the wire and I toss it out the window so that none of the wire is in the house. The wire is laying on the ground. If lightning strikes the wire, it will carry it to ground. But again, it's something that you have to implement when you build an antenna. Okay, so first, let's look at a handful of diagrams before we go on and look at the real stuff. One of the antennas we'll consider today is a gutter antenna. When I was a kid, we used these. You just take some brass washers, stainless steel washers, anything that won't corrode, tie it to a relatively flexible wire and throw it in the gutter, and hook the other end to your radio, and it produces surprisingly good results. Now, there's a couple conditions. Your gutters have to be metal. They cannot be painted on the inside, and they cannot be grounded. But if you have those conditions, a gutter antenna works rather well. Gutter antennas are susceptible to lightning, so when you're done, you definitely have to take the antenna down. But again, easy to do, doesn't change the look of your house, doesn't take any serious work to install. Next, we have the end-fed long wire, and the components are going to be insulator, wire, and then we'll talk about grounding. So let's start over here on the right side. We have some place to tie our antenna to, the dead end of our antenna to. We need an insulator to keep the wire from touching that thing. And then we run the wire along, attach it to another surface with an insulator, and then we run the wire down, the feed line down to our radio. Also, we're going to need a ground. So ground is simply a wire that goes out and goes into a ground stake. I'll talk more about that in a bit. The feed line should be away from the house as much as possible. When I did my other antenna, when I did one of my antennas, I had to go near the house. It definitely impacts the quality of the signal. So as much as you can, keep it away from the house or other structures. And you also want to make it high enough above the ground that you get a good signal, but you don't want it too high that you can't maintain it. The third antenna I'll talk about today is a T antenna. And as you can see, it looks like a T. The blue line looks like a T. Same components. We need an insulator, we need the antenna wire, and of course, as always, we need the ground. So what we do is we attach both ends of the horizontal wire to a house or other surfaces, and then we have another insulator which helps holds the weight of this line that descends down to our radio. So the feed line is attached in the middle. Typically you want to solder that. In fact, I would strongly recommend soldering this point right here. But this antenna is very nice because if you mount it under the eaves, you can keep it away from rain, sun, and wind quite a bit. You can also mount one of these in the attic. When I was a kid, we mounted one in the attic. It removes a lot of issues with things like lightning, sun, rain, wind. You can use a relatively thin wire and you can run it a fairly long distance. So yeah, that works very well. Sources of materials, types of materials. A ground rod is any metal rod that does not corrode easily, usually 2 meters or more long, and you can buy these at electrical stores, hardware stores, and similar. Antenna wire. Copper is the best, easiest to work with, easy to find. Aluminum, stainless will work, but they're less preferred because they're harder to work with, they're more expensive, and they do have higher resistance, so you won't get as good a signal. To buy new wire, you can go to electrical stores, stores that rebuild electric motors, which is where I got mine. Hardware stores, ham radio stores, they all have new wire. For used wire, you can unwind a transformer, a solenoid, or electric motors, and I've done that frequently. For insulators, you can use plastic, glass, ceramic, anything that does not carry electricity. They come in different configurations. There's a dog bone, egg, bobbins. To buy them new, you can go to electrical stores, ham radio stores, or farm stores. Farm stores sell electric fence insulators, so those are good. For DIY type of insulators, I use plastic PVC plumbing pieces. Acrylic strips will work in a very similar way. You can get a shower curtain ring that are solid plastic, or plastic rope and string also works, not quite as well, but it works. And then things like plastic clothes hoops will also work. When you're putting up your antennas, you can try different things. You can try like the temporary antenna, you can try a long wire V, inverted V. These are more complex, but as you're becoming more acquainted with crystal radio, you can try the more advanced antennas. You can try different orientations, so you can set up one antenna north-south, another east-west, another somewhere along the diagonals on those. You can try to use multiple antennas simultaneously. I found that works rather well. If you have 2 or 3 antennas, you can hook up one or the other or both at the same time. Grounding, you can use your ground rod, you can use no ground rod. Sometimes I found this works for some of the stations around here, it works best. Or you can use a second antenna as a ground, and I've also found that that can work very well. You can also try different things with your radios. You can put it on a metal table, wood table, you can orient it differently. You can put your hands or body near it, take it away, move it near the coil, and so on. Okay, so let's talk, go over some dangers about setting up antennas. First of all, there's working at height, working on a ladder, anything like that. Yeah, there's danger of lightning. We discussed that earlier. So when the radio's not in use, disconnect it, move the end outside. Never use an antenna or a radio that's attached to an antenna during a storm or if a storm is coming. And again, you're going to need lightning protection from all outside antennas. Never run an antenna near or across an electric line. If the antenna breaks and drops onto an electric line, that's very serious. Do not run antennas where it's going to strike someone in the face or throat or something. Yeah, that's also a danger. When you're driving ground rods, make sure there's nothing underneath the soil, electrical, water, or gas lines that you might drive through. If you don't know, check with your electric utility company first. And with all this stuff, if you don't know, if you have questions, learn first or don't do it. Okay, enough talking. Let's go on and look at the real things. We'll start out with construction methods. What about the type of wire you're going to use on your crystal radio antenna? Well, that's also important. The easiest to find is copper wire. It's the easiest to work with. It's the cheapest. You can find it just about anywhere. Steel wire and stainless steel wire, aluminum wire, they don't carry electricity as well, and they're hard to solder if you choose to do that. So typically I just use a copper wire. You can like unspool a transformer. This wire was unspooled from a fluorescent light ballast. These are some bell wire that I had left over from another project. So any of these make a really good antenna wire. And also thickness. A thicker wire is typically better, but if you use it down low, there's always the danger that somebody will walk into it and cause themselves injury. So if I'm going to string an antenna down low, I usually use something that's going to break if somebody walks into it, like this one. And yeah, otherwise I'll use a thicker wire up high where, you know, if a bird lands on it, it won't break or something. But for wire, that's about it. Any good quality copper wire should do you. On each end of your antenna wire, you're going to need an insulator to keep the antenna from touching anything that might carry the signal away. So on whether you're mounting it between two poles or your house and a pole or a tree or whatever, on each end of that antenna wire, you're going to need an insulator. And this is a very easy way to make one. It's just a piece of 1/2-inch PVC with holes drilled in it. On one side, where you're going to attach it, say, to a pole or a tree, you just run a wire or string through here and attach it to wherever it's going. On the other end will be your antenna, and you'll pass this loop, will go through here, and then you'll tie it off like this, and then the wire will run out across your yard or wherever you're setting up your antenna. So this is a very cheap and easy way to make an insulator. Another option for insulators is something like this polypropylene string. It's very coarse and it won't collect water. Water won't stay in it very easily. You don't want to use something that's really like a fine fiber that'll hold water for a long time. But this works as a fair insulator, and actually I'm going to use it to tie up some of my other insulators. So anyway, polypropylene string can also be used as an insulator. On each end of your antenna, you're going to need to attach it to the insulator, and that insulator will then be hooked to your house or a pole or something like that. So here's our two simulated end pieces for our antenna. This side will be the antenna. It will go running out across the yard, and this side will go down to our radio, rather. And as you can see, they're pretty much the same. I mean, one's bare copper and the other is insulated. And so this one comes in here, has 2 turns of wire, has 2 turns of wire here. The same here, 2 turns of wire, 2 turns of wire. So what's the difference? Okay, well, let's take a look. This, because it has insulation on it, the signal will come in here like this. It will go through this coil of wire, and a coil of wire creates inductance and capacitance and all sorts of things. Then it will come around here and it'll go through another 2 turns, which will change the inductance. So here I've got a choke and here I've got an inductor, and then it will pass through the radio. This is a problem. I'll show you why. Let's look at the one that's not insulated. This one, the signal comes in here the same, but it hits this and it immediately goes down to the radio. It doesn't pass through the choke and it doesn't pass through this coil. So yeah, this is the better way to do it. If you can solder it, now this one I soldered, if you can solder it right here, that's a better thing. But if not, using the bare wire will help assure that your signal doesn't go through this choke and this coil and possibly upsetting your signal. So when you're attaching it to your insulator, this is something to consider. I would personally prefer to use insulated wire, or sorry, non-insulated wire, and if it is insulated, remove the insulation, whether it's this plastic insulation you can peel off, or if it's enamel type insulation, you can scrape it off at least at this point so that the signal will go from the antenna directly down this wire and not pass through this. Okay? So that's one end of the wire. The other end of the wire is simply a loop. Same type of thing applies. You don't really want a choke here. Again, I've soldered this just because it's stronger. It won't slip that way. What I did is I looped this around the insulator and I tied a knot in it, just a simple knot, and I took the tail end of the knot and I just wrapped it around here. Now this is a really stiff piece of wire, so it's harder to work with and it's not as beautiful right here. With a thinner piece of wire, this will be a lot lower profile. But yeah, just something like that to secure the other end. Again, eliminating any unnecessary looping or such in the wire. So I will show you this. This is the brass washer set in the gutter. That's just a standard gutter. Make sure it's in there touching the bottom, and then we'll go listen. Probably gonna have a lot of wind noise, but let's give this a shot. So the wire comes over here, goes up here, up to my insulator as we discussed. I did solder this joint right here to make sure that I had a smooth flow from here down. Polypropylene line. And then along here, let me let the camera adjust. Up here where I cheated because it's too close to both the members, so I used another insulating string to hold it in between there. And then it goes all the way out there. That's as long as I can make it. Out to this insulator. And again, it's soldered here. The insulating line, and then also this is a good insulator, and it's tied to our security fence. This is going to be hard to see. This is where I'm at my T antenna. I've got one insulator here, and it hangs underneath out there. Let's take a closer look at this. This is the center connector. You can see I've got the polypropylene cord to the top, and then I got the wire strung from one side to the other, and then teed off of that is the wire going down to the radio downstairs. So that's the center insulator. Then the other side is over here, tied on here using the polypropylene string, and there's the insulator. There it is, you can see up there in the middle, and it runs down. Right here I made a joint to go from the enameled wire up here to a yellow wire because unfortunately I have to run close to the house and down through a hole. I'm going to lose a lot of signal doing this, but that's life. I can't run it any other way. So sometimes there's compromises. Let's keep going down and look at that. My antenna wire comes from the roof up here. Comes down the wall. That's where it's too close to the house. And enters the house here. Also, I've got a ground wire that's attached to this steel that is hooked to the house frame, so that's a good ground. Okay, so let's go inside and do a test. I'm using this modified Boy Scout crystal radio, and one thing I found is it doesn't have the discrimination of my capacitive tuning crystal radio. And one of the problems is this antenna works so well, I pull in so many stations it's hard to separate them. But anyway, let's give a listen and see how it sounds. This is the T antenna. That's the end of our video for crystal radio antennas. It's also the end of our remix for the basic crystal radio videos that we have that can help you get started in the hobby and take you through all of the steps you need to start exploring on your own. Okay, if you're interested, we got more videos. Please check those out, lots more detail. And thank you for watching.